Hi everyone. Welcome to today's session for Java Collections API. Today we'll be discussing about everything that comes under Java Collection API, be it hash set, hash map. You'll get to know what all these means and how do they perform and how they can help you efficiently store data and also query on that. Right. So let me let me introduce myself first. So my name is Ashish Gulati. I'm a software developer currently working at Kotak Mahindra Bank. I have around 4 years of experience, majorly in Java backend development, and I graduated in 2020 from Delhi Technological University. So let's begin. So I'll just present my screen. Right. So first, let's just see what exactly is Java collection. Right. So I hope you can see my IntelliJ screen. Just, just a second. Right, right. So first, take a look at what exactly is a collection. Any guesses? Okay, I'll tell you. Right. So a collection is nothing but A collection is nothing but it is a data structure to store the data. Right. So any data structure which can store data comes under collection. Right. So be it array, if you have heard about some of them, be it array, list, map, set, queue, or yeah. So these are the primarily used collections, right, in Java. Right. So we'll discuss each of them one by one, and we'll know how they, in what scenarios, which one is actually very useful. Right. So first, let's talk about array. Right. So array is actually uh, the most primary data structure used in any language, right? In any computer programming language, right? It is contiguous in nature, which means that you can store data in a contiguous fashion, right? So whatever you will store, it will get stored one after the other, right? So the memory addresses will be one after the other. So let's say I have something like, let's say an array of, let's say, 5 elements, right? So let's say it has 1, 2, 3, 4, and 5, or let's say six, right? So in memory, um, when I'll be at one, I know that two is stored at the next location, right? So they will both will be stored one after the other, right? So this is how they will be stored in the memory, right? So they are contiguous in nature, correct? So yeah, so this is about array, right? Coming to the next one, or okay, let's just see how we can use arrays, right? So okay, mm, okay. Let's say you are given an array of numbers, and you want to find out the last, the second last element in the array. So basically, it's about the accessing of how you access in the array, right? So that's what we are trying to see here, right? Right. So let's say I have an array of integers, right? And right, a- and sorry, okay. So let's say its size is 5, right? And let me store, let's say at zero index, I am storing 1. At 1th index, I am storing 2. Again, at second index, I'm storing 3. Third index, I'm storing 4. And similarly, at final index, I'm storing 6, right? So I want to find out, okay, or let me do this, right? So, huh, yeah, so let's say, so now want to find out the second, second last element in the array, right? So what will you do, right? So first thing is, we can find out the size of this array using this array dot length, right? That we can do. Sorry. Right? So it's a property inside this array, right, which you can use to find the size of the array, right? So the last element gets stored at your length minus 1th index, right? So it starts with this is 0, 1, 2, 3, 4, right? The size of the array is 5, and array of size minus 1 is actually the last element, right? Right, so let's say I want to print the last element. What I'll do is, what I'll say, array of size, right? And I'll just simply print. If I run it, okay, so this will give me error because, yeah, index 5 is out of bounds for length 5, right? So that's what it's because there's nothing at array of 5, right? Because it starts with 0 and goes on till array of n minus 1 or array of size minus 1, right? So this would print me the last element of the array, correct? Which is 6, right? So I, so I hope you got what I'm trying to say here is, you for to find the last second last element in the array, you just need to do array of size minus 2, right? You'll be able to get. And similarly for the other indexes as well, we can do that, right? So this is how you can access an element in array, right? I'll just comment this down. Right, so this is about how you access element in array. And if you can see, we are able, by just mentioning at what point we want to get the value, we are able to get it because the members in the array are actually stored one after the other. That's where we are able to get each element, correct? Right. So coming back to your collections, right? So this is about array. So this yeah, so this is about array, first one. So coming to the next one, I think I already mentioned here, array is contiguous in nature. Let's talk about the list, right? So a list is nothing but an array of any data, right? It's also an array of data, but this is actually non-contiguous in nature, right? And also it is homogeneous in nature, just similar to array, it's also homogeneous in nature. It can only store a single type of data, right? So we'll see. Okay, let me give you some examples of list, right? So array list is one very common example of list, right? And also similar to array list, we have linked list. We'll see what how these all help us, right? Vector is also an example of list, right? Correct. So let's just see how what exact list interface, right? So this is actually the side interface of the collection interface, and we can store ordered collections, right? So let's just see one after the other, right? So let's talk about the array list, right? So array lists are actually, these are just similar to arrays, but they are dynamic in nature, right? So when I say dynamic in nature, or they are just dynamic arrays, that means you don't need to define the size, like how, um, what size of list you'll be having or what size of array you'll be having. Instead, you can just define a array list, and done. That's it. You can change the size dynamically while actually using it. You can add more elements to it, even beyond the size, right? It a bit slower compared to it is a bit slower compared to standard arrays, right? But it can be very helpful in programs, right? Right, because where manipulation is where you want to manipulate the data, right, or manipulate the array. Because see, if you are using array, you need to pre-decide that what size you'll be having, right? But if you are using dynamic array or array list, you can change the size. I mean, you can add more elements on the go, right? Right. So, but let's see how the size can gets increased, right? So the size is increased automatically if collection if collection automatically, let's say, it let automatically if collection grows, right? Let's say if the vector is growing and it reaches a point where it can't accommodate more members, right? The size will go automatically. It will automatically increase the size, and similarly it will shrink the size as well. If we keep on let's say initially it is assigned to, let's say, store four elements, right? And let's say three elements are already filled, so it will keep on it will increase the size of the array list, right? And similarly, let's say now only five elements are remaining, right? So it might shrink the size as well of the array list, right? So let's see how we can use an array list, right? So let's try to define an array list, correct? And let's say array list, right? I'll tell you in a minute that which ideally we shouldn't be writing like this. We actually should be writing it like this instead of actually programming to a concrete class. We should be programming to uh, interfaces, but I don't want to confuse you as of now. I'll explain you first, and then I'll show you why. Then I'll tell you why we should program to an interface rather than concrete classes. We should be writing like this, right? But for now, to keep things simple, I'm just using array list only, right? So this list is actually the parent class of all this. So let me also show you, right? So let me go ahead and open it, right? So if you'll see the implementations of it, you'll see here array list, yes, right? Also, if you go down, you'll be able to see the other stack, queue, vector in all this, right? And the others as well. Linked vector, linked list. Yeah, there's linked list, right? So all these are there, right? So all these lists are all these array lists, linked list vector are actually coming from the same list interface only. So list is the interface, and all these are concrete classes or the implementations, right? Right. Okay. So let's say for let's say I equal to 0, and if I go on till, let's say, 10, I plus plus, right? um, okay, this, let's say I add, okay, let me also show you the add method as well, right? So inside this there will be an add method, which yeah, this, right? This helps split out from add to keep method, and this is a private method, right? Okay, let me go and show you in the list, right? So there would be an add method here, right? And this as well, right? We can add it to some index as well, right? So you can go read it, read this documentation at a specified position in the list, right? So that's what I told you, right? So if you want to add it to a particular position, you can do that as well. But if you want to, let's say, just add an element basically to the end, so you can use this function, right? Append the specified element to the end of this list, correct? right? Similarly, this would be present in the array list as well, right? Because it's just an implementation of the interface, correct? So I'll be using this add, and you can see here as well. So one is this and the other one is this, right? So let's say I add an element. The element, let's say I'm adding I plus 1, right? So starting with 1, I'm adding till 10, correct? So this you can say this is one of the operation of collection, which is actually provided by the collection API itself. Most of the collections will have the add function, right? But we'll see. It might be there in some, it might not be there in some. So we'll see that, right? So let me go ahead and actually print this array list, right? Let's see if we are able to do that, right? If I run it, right? So you can see the list got printed, correct? So this is how you can add it, right? And if you see, we didn't add any length, right? And let me also show you array list dot size, right? And let's go ahead and actually see it for 100, and I'll say here I print size, right? And let's just see, okay. So it's growing incrementally, right? So the size is getting increased one after the other, and that's what, right? So it's, so the number, the size would actually give you the number of element it has, right? And you can always go, you can just press the command button, and you can go inside, and it says return the number of elements, right? And this grow function which I was saying, see, what exactly this is doing is it's actually growing your list. That's what I told you here. Okay, if we go back, I mentioned it, size is increased automatically if collection grows. So that's when this grow function would be getting called internally, right? So let's see where this grow function is getting called, right here. And this grow function would also be getting called somewhere, right? So increases the capacity of this array list instance if necessary to ensure that it can hold at least the number of elements specified, right? So the minimum capacity which is mentioned, at least that much elements would be there, and it will keep on increasing it, right? So let's see this in ensure capacity, right? So you got the point, right? So internally the grow function gets called, and the size will keep on increasing, right? So let's explore some more methods here. Let me actually remove some element. So let's say I actually call this remove, and I call this integer, right? And I want to actually remove the fifth element, right? So can anyone guess what element would actually be increased or removed uh, out of this? So 0, 1, 2. I'm guessing the sixth element. The sixth element would be removed, right? But let's see, right? So as you can see, that 6 got removed because it was present at sixth index, right? That's what we told the program to do. That just remove the sixth element, right? I'm actually commenting it down, or let it say we'll comment the complete one, right? Now we can also this is how we can print the complete list, but there is one more function we'll be able to see. Let's do for int I equal to 0, I less than 100, not 100, because we have removed an element. Let me just, so this is where the functions actually become helpful, right? So you can actually do array less than size, right? Because see, we removed one element, right? We knew the size is 100, but now the size is 99, right? So we don't have to worry about that. We can directly do less than equal to array dot size, right? So let's do system dot out dot println, and now we need to get each element one by one, right? So let me say element this plus the index, right, plus this, and after this let's say this, and then what I'll do is so let's see how we can get it. So it's as easy as that, right? So we want to get an element, so you'll be using the get function, right? And let me do so. See, if we go inside, it will say at index, so we need to mention at what index we need the, I mean, which index element we need, right? So if now I go ahead and actually print it, let me remove this, right? So you can see element 0 is 1, 2 1 is 2, and 6 is removed, and similarly at 98 it would be 100. Ideally at 99 it would have been 100, but since we removed one element, so it so now element at 98 is 100, right? So this is about array list, right? Let me also comment this down, right? So let's explore the other ones as well, right? Let's explore the linked list. I hope everyone, I mean, whoever is watching the session live or after the recording, is aware about the vector, sorry, the linked list. If not, you can first read about the linked list, right? So linked list, so in Java, the linked list is nothing but the implementation of the linked list, right? So Java provides an out of the box implementation of, right, linked list data structure, of linked list data structure, right? And linked list data structure is actually nothing but a linear data structure where elements are not stored in not contiguous fashion, contiguous manner, and also every element. Okay, so this is where this is different from an array list. I'll tell you, every element is a separate object, separate object, right? And basically the separate object has a data part and address part, right? So basically it contains the address of the next location, right? So that we can go directly to it, right? So let's just see, let's declare a linked list and we'll play around with it, right? Let's say okay, sorry, let's have a linked list of integers, right? uh, and let me do for again I'm doing the same thing, right? It's almost similar, so you'll see linked list dot add I and I plus, let me do I plus 1, and when I'll print it out, it will print exactly like your, okay, let linked list, right? And dot, let's say I also remove the fifth index, right? Then I mean it's similar, we can actually copy paste the complete code. You'll see it's mostly similar. Internally the implementation might differ, but behavioral wise you won't see much difference in both, right? The function which it provides, you won't find much difference, right? So let me just run it. Right, so similarly we are also able to get here. And okay, I removed the part where we are removing, so let me also add that. Right, so here you see, okay, yeah, so the sixth in now we are actually removing the sixth element, right, instead of fifth. So that's what, right? So this is about the linked list, right? So now coming back to the third one, which is basically the last one which we'll be discussing here. I mean for array list, right? So now comes vector, right? So we have talked about array list, linked list, and now vector, right? Vector is again just like array list. It is dynamic arrays, right? Again, these are identical to array list in terms of implementation, but the primary difference. Let's talk about the difference actually, because identical to array list, but the primary difference is that vector is synchronized, right? And while array list is not. So synchronize, you'll learn about synchronization once you get to know about threads, but basically it doesn't allow multiple operations to be performed on it, right, at once, using different threads as well, right? Okay, let's create a vector. So I'm quickly going over this because it's similar to the other lists which we have talked, right? So let me do what? Let me just copy this and just paste it and just show you that these are all just similar functions which each of them provides, right? And if I go ahead and run it, again you will see the same result, right? So all these are okay, and I think I did not write stack, right? So there's one more stack also is there, right? Right. So, right. So as you can see, the most of them are actually similar, right? And all these are actually implementation of the list interface, right? So the interfaces, since this interface is same, each of them would be behaving similarly, right? So let's talk about this tag now. This is something different, right? So stack model actually, this is an implementation of again, I'll tell you, if you haven't heard about Stack, I would recommend you to first learn about Stack data structure, right? And then you'll be able to get this, right? But I'll try to explain, right? So it's actually an implementation of Stack data structure. Again, the Stack data structure is a type of data structure which follows first in, sorry, LIFO, right? Which means last in, first out, right? So it's like a you can think of it like a container, right? Let me show you. Right, so stack is something like this. So other data structure, you can assume it to be like this, right? Let's say this is an array, right, where one is stored, two, three, and then four. Let's say this is a stack data array, right? But stack is stored something like this, right? So the values are actually dumped into in a last in first out manner. So let's say one is stored first, then 2, then 3. So basically, since the 1 was stored in the beginning, so it went to the last location. So when now I want to, let's say this is my stack, right? This is how it looks like. So in order of insertion was 1, 2, and then 3, right? But when I'll be taking the elements out, I'll be getting 3, 2, and then 1, right? This is because it actually reverses, it follows the last in first out ordering, right? So I hope you're able to get it. So let's see what all functions it provides, right? So a classic example where this stack can be used is, let's say you want actually to reverse a, let's say you want to reverse a string, right? You, what you can do, you can push each of the characters one by one, and when you will be taking it out, it will be reversed, right? So this is a classic example. And also in function, you must have heard about function call stack, right? So that also uses stack, right? So let's say, right, so let's say we have a stack of strings, and reverse a string, or maybe reverse an array of string, that also can be, right? So basically reversal, you understood, right? Basically it reverses everything. So any scenario where you want to reverse something, you can use that, right? So let's say we actually let's say I have a string of arrays, right? But let me just push each of them one by one. Or let's say, let's say and okay, I don't think we need an array. Let's directly push it. Right, let's say geeks and for geeks, right? And geek for geeks development, right? The spelling is wrong, but yeah, fine, right? So let's say now I want to actually reverse it, right? I want to the strings to be printed in a reverse manner, in a manner in which the reverse of what I how I inserted, right? So now we'll be using an iterator class to iterate through. So this iterator class can be used everywhere to iterate over any I can show you for others as well, right? So let's just first do this, and then I'll show you for others as well. So here I'll say I want an iterator to iterate over a stack. That's why I this iterator is a class, right? And if you'll see, all these classes are actually, and there you will also find basically all the iterators are actually implementing this iterator class, right? So if you go to stack, there also you'll be having, if I search for iterator, right? So oh sorry, if I go back to vector, so it's coming from uh, right, yeah, since it's coming for vector class, so basically, yeah, here we have the iterator, right? It must be there somewhere, right? Let me just check. Uh, right, this is there's the iterator class, right, which has been implemented, right? So we have has next function and we have next function, right? We also have this remove for each remaining. All these functions are there for iterator class, and every class actually needs to implement the iterator class, right? Every collection class. It also says, you know, returns an iterator for elements in proper sequence, right? So you can read about it, but yeah, you understood the crux, right? So now we got the iterator, and since I already showed you, let's say what all functions the iterator provides, has next and next. So next element will actually get you the next, wherever the iterator is pointing to, it will get you the next the value there, right? And has next will check whether we are still left with elements in this collection or not, right? So let's check for has next, right? And what I'll do, I'll say iterator dot next and done, right? So this is what I'm printing, and after that I'll say, let's say I do stack dot pop, right? Let's say I do stack dot pop, and now if I, okay, let me first print this and then we'll see, right? So now you see Geeks for Geeks development, this is what got printed, right? Right, because we are iterating through each of the element one by one, right? Right, that's what we are doing, correct? And let's say I actually, okay, let's, instead of using this iterator, now let me show this is how it got inserted, right? So instead of this, let's use the stack functionality now. Stack dot, while stack is non-empty, while not of stack is empty, that means till the time it is not empty, I'll do system dot out dot println, I'll say stack dot first element, right? And after this I'll do stack dot pop, sorry, not push but pop, right? So this pop is nothing but it removes an element, removes the object at top of the stack, and similarly this stack dot first element will get you the first value, right? So now you see, okay, not the first element, stack dot top, sorry, dot peak, right? Right, first element will always get you the first element, uh, right? So it says development geeks for geeks, so that means it got reversed, right? Inside this it got reversed, and this is how you iterate through the elements. So that is also, and now let me show you, let's say I do this also stack dot pop. So let's say can any cases which element will get removed. So since I'm doing stack dot pop, right? So this development would actually get removed, and not geeks, not the first element, right? So it says geeks for geeks. So the last element, that means it follows last in first out. Whatever was the last in, it's gonna come out first, right? I hope you understood, right? And okay, now this was about your list. So we have covered list, right? So first array is done, list is done. Now let's talk about okay, okay, since we have already covered list, right? So let's talk, let me actually give you one question, quick question, and you can try to, pause for 5 minutes and you can try to think of a solution, right? So let me post it here, right? So the question is something like, you are given an unsorted list of integers. You need to find out the first pair whose sum is equal to target, right? And if no such pair exists, you can return, we can return -1, right? Let me explain. right? So let's say the list is, let me give you an example. Let's say the list is 1 2 3 5 7 4 5 7 4 8 10 20, right. Let's say the list is this, right? So now what we, and let's say the target is maybe let's say 15, right? So now if you think about it, right? So have we covered set? Okay, no, right? Okay. Let's just pause this for a minute. I've written this down, but let's first do the set interface, and then we'll come back to this question. I let me actually, let me paste it here, right? So this was about your list interface. This is about your this. The other one was about array interface. Now the third one, set interface, right? I think, yeah. So okay, let me just change the order, right? So coming to the set interface, right? So a set interface, what does a set interface does is store data without duplicates, as simple as that, right? um, Basically, whenever you will store data in a set, duplicates values cannot be stored. That means duplicate values can never be stored, right? And obviously this, why would you be using this? when we when we wish to avoid storing duplicates, right? And store only unique objects, right? Example of set interface, one is hash set. We can actually go ahead and check inside. Okay. It's written like hash set. Then we have tree set, we have linked hash set. So we'll be discussing primarily these one, right? Okay, correct. Right. So first let's talk about the hash set. Right. So this is an implementation, classic implementation of hash data structure, hash table, right? So values are stored in a hash table, right? And the values. Oh, okay. So yeah, please note this. This will help you. The whatever I'm mentioning, this will help you differentiate the hash set from a linked hash set, right? So ordering is not. I mean, ordering is not. What do you call? Guaranteed, right? So it doesn't guarantee the ordering of elements, right? And also, since it's a hash set, uh, ins- elements are inserted based on hash value, hash code. And also, you can insert null elements as well. right? So let's just quickly see. Let's do this, right? Let's have a hash set of maybe let's say string, right? And let's take the same example, Geeks for Geeks development, right? So there you will be able to see. Let's say I actually add Geeks, and let me do command D for Geeks development, right? And now you'll be seeing that we actually use the iterator class. Iterator is equal to set dot sorry, we'll use asset dot iterator. Right now, while this I've already explained you, so I'm going fast over this. Dot has next, we'll be printing has set dot uh, sorry, iterator dot next, right? Okay, let's print this, right? So you see Geeks for development, right? And let me okay, let's do one thing. Let instead of this, let's have development first, and here I'll have Geeks, right? So basically we are seeing the values, right? And it uh, we are getting what we wanted, right? We have successfully removed the duplicates, right? So okay, this is about hash set, right? Let me comment this down, and let's come to linked hash set. So here the ordering is very important, right? It's similar to and it is a implementation of doubly linked list. It's like a doubly linked list, and it retains ordering. That's what I told you, right? So the main difference between a linked hash set and a normal hash set is it retains the ordering of elements, right? So let me just copy this and show you, right? Let me uncomment this down. Instead of hash set, we want to replace it with linked hash set. Sorry, linked hash set, and everywhere. The name is hash set, but don't get confused. It's actually linked hash set, or maybe right. And if I run it, so this will also remove the duplicates, but the ordering would be maintained always, right? That doesn't hash set doesn't guarantee. It might retain, it might not retain, but linked hash set will always guarantee you that the ordering is maintained. And one more thing to note here is, let me show you. I told you that I'll tell you in a while, but yeah. Okay. So as you see, all these are actually quite similar, right? And what you will be doing is, let's say this was coming from, this is coming from a set class. The other one is actually coming or from your also coming from a set class, right? So we can actually use it like this as well, right? We can mention the uh, interface on the left, and we can do here. See here, I can use linked hash set, normal hash set, right? I can preset. I can use abstract set. I can use any one of them, right? I don't need to actually go ahead and change it, right? So again, the reason why I'm saying so, I'll explain you in a minute. But yeah, you can do that. You can always say set of this, right? And similarly, here also you can say where is it? Here also you can say set of string, right? So you can always do that, correct? So this was about your set interface, right? And now let's come to the map. Uh, did we discuss queue? I think we haven't, right? But let's first see the map interface, and then we'll come back to the queue, right? Let me comment this down. This okay. So we have covered set. Now we'll cover map, right? Again, now a map is a data structure which can actually help you. A data structure where you can store key value pair, right? Where you can store, it's like this. For every key you can store a value as well. For now, we were just storing the values, right? In the set also we are storing geeks for geeks, but let's say there's a key value pair. Let's say you have keys like, let's say name is this and class is this, something like this, right? Then this using just the set won't make sense, right? We would be needing which support storing key value store, right? Basically it helps, since the name suggests mapping of data also, right? It helps you support mapping of data. And again, this also, since it is based on your hash, right, it doesn't allow duplicate keys, right? Because why? Because same key can't be mapped to multiple values, right? Right. So let's see. First, let's talk about hash map. Right. We'll be discussing hash map only. That is the most important use map map concrete class. Right. So let's see how hash map performs. Right now, you'll be seeing that I'm using map of integer and things like that. Right. I'm not using hash map on the left side. I'm actually using the name of the interface rather than just the class. Let's say I want to store a key value like map of integer comma string. Let's say hash map is equal to new hash map, right? Uh, right. So let's see what all function it provides so that we can store the value. So here you see, you will be seeing one put method, right? So inside this, you'll see integer comma value. So this function can be used to put values inside a hash map, right? So let's say at first I want to store geeks. At second place, I want to store for, and at third place, I want to store again geeks, right? So the values can be same, but keys need to be unique. You should understand that, and you should remember this, right? Let's say I do. Let's say I want to get the first value, right? So how I can get it? Using this again, get, right? And I'll mention the name of the key. Let's say I want to get what is stored against 2. So I can use this and I'll get 4, right? Right. And now if I want to iterate over this, right? Let's say traverse. So let's see if iterator can help us here, right? So let's say I'm use iterator class and I do hash map dot iterator, right? But here we have entry set dot iterator or key set dot iterator or right. So let's see what we mean by that, right? So for we'll be using this. Okay, this won't be just an iterator. So I'll just show you. So we'll use a for loop, right? And I'll do map dot entry, right? And inside that, uh, sorry, not this one. It's map dot entry. Inside this, I'll mention what is my key value pair, like what data type are they will do they belong to, and I'll do hash map dot entry set, right? So this entry set returns you set of entries of integer comma string, right? So, okay, let me actually show you what each one contains. Let me just print this E, right? Okay. Uh, oh, sorry. It won't be equal to, it would be this column, right? So here you see, it prints one equal to geeks, two equal to four, three equals to geeks. It prints something like this. But let's say you just want, if you just want to know the value and not the key, or just the key and not the value, you can do e dot get key, and also you can do not plus instead this e dot get value, right? So this you can do. So now you'll get one colon geeks, two colon four, and three colon geeks, right? Just like this, right? So this is how we can use hash map as well, right? So this was about the map interface. You can, if you want to know like more on map, you can go ahead and explore, right? So you can see all these are implementation of hash map, but only the primarily used map would be hash map only, right? So that's why I covered that one, right? So okay, let's actually go ahead and do couple of questions, right? By the way, one short, okay, tree set, did we discuss tree set? Right, we'll, I think we'll did not, right? So it also comes under this set interface, but I'll explain you differently, right? It actually is a set interface, but it is a sorted set interface. It belongs to sorted set interface, right? Okay, so a tree set uses a tree to store data, right? And ordering is maintained by a set, right? Right, and we can use also use a comparator inside this, but yeah, let me just copy this. Let's see what I mean by this. So this would be preset, go to new preset, right? So now if I print it, you'll see it's mostly same development for geeks, right? And the ordering is maintained, right? And what difference it has, we can use a comparator to store to order data at the time of set creation, right? So this is about reset. We just left with queue, but for okay, but let's first discuss this question now, right? uh, okay, so okay, let me remove this, and now we'll be talking about the question, right? So let me explain. So we have unsorted list of integers, right? What we want to achieve is we want to get we want to find the first pair whose sum is equal to the target given, right? So let's say this is the list. I want to find what is the first pair which I mean both the elements which can be whose sum is equal to target, right? So if you see here, uh, sorry, uh, what would be the answer? I think it would be 5 one is 5 comma 10, but if you look closely, you'll see 7 comma 8 also equals to 10, oh sorry 15, but 7 and 8 are both are coming prior to 10, right? So that's what, right? So this is what we want to achieve. So I'll pause here for 5 minutes, and you can think about it, and then we'll discuss the solution, right? Yeah. So welcome back. Uh, I hope we have gone through the question and you must have some sort of solution in mind, right? So let's discuss, right? So let's see, based on the type of data, based on the different data structure we have used, right? Let's see which data structure would be efficient here, right? So first thing first, what do we want out of here? First is we want to find the pairs, first pair whose sum is equal to target, correct? So we want to see, right? So let's say I am at 1. I want to check whether I can find any other member by any other member with which I can make the total sum equal to target. What I mean by that is, let's say I'm at 1. So I want to know whether I have encountered any other element till now whose sum is whose value is equal to, I mean, whose value plus my value is equal to the target, right? So how we can do that? Basically, let's say I am at, let's say I am currently at some ith element. Its value is array of I, right? And so I want to know whether there exists any other j, right, whose value of j, or basically array of j, not whose, such that array of j plus array of I is actually equal to the target value, right? So as simple as that, right? But how is this helpful? How can this help me find a solution? Let's see, right? So I'm just modifying this equation only. So I'll say I want to find an array of j such that its value is equal. I know the value of array of I. I know the value of target, right? So I can do this, right? Then I'll get some value, right? So let's say my array of I was 1 and target, for example, let's say my array of I is 1 and target is 1. So I need to know, oh, sorry, my area of I is 1 and target is 15. So I need to know whether a value exists such that its value is equal to 4, whether a member exists whose value is 14. But how would we search? Would we search the entire array? Uh, array for it? Okay, I'll show you. Let's say I, and also since I want to find the first pair, that means the other element must have already be present in the left side of the array, right? Let's say I am at 1. If the 14 is present here, but that doesn't guarantee me that any other similar to this, let's say I'm at 5, right? Let's say array of I is 5, and I want to find whether 10 is present or not. But 10 is not present on the left side. Right side won't matter, because when I come to 10 here, then I can check whether 5 exists or not, right? This would guarantee me that the result I will be getting is the first pair, because let's say I'm at 7. So till this point, for both the pairs 5 and 10, 7 and 8, I have only gotten the first element, not the second element as well, right? When I'm at 8, it guarantees me that 7 was already there, 8 is also there, so the sum of both the elements is equal to 15. So this guarantees me that this complete pair is present on the first, like this is the first pair whose sum is equal to target, right? So basically I want to store all the elements encountered till now in some sort of data structure where I can search efficiently, correct? And also the duplicates, also I don't want, I mean, even if the duplicates are gone, I don't care, but I should be able to search efficiently, right? Right. So let's see whether there is an existing data structure for it, right? We have discussed set, right? So set can store values, it can remove duplicates, and even the searching part also. Let's see, right? Let's say I declare a set. Okay, this, I'll add the solution here. Let's say I declare a set for integer, and let's say I use hash set, right? Because we don't care about the ordering, right? Why we don't care about the ordering? Because any I mean it could be present at any point, right? And now let's see set dot contains, right? So this actually will help you find, it will return true if the set contains the specified element or not. More formally returns true if and only if this set contains an element, right? So this can actually help me find whether this it contains some value or not, right? So this is really helpful in this question, correct? Right, so now I declare a set. What I need to do, I need to store all the values encountered till now on the left side, and I need to check whether array of target minus array of I is present or not. Simple, as simple as that, right? So let me define the target here, right? First, let's have a list. First list of, let's say, integer, new array list. Or no, sorry, I mean we can actually use arrays dot, because we want to, right? Here I'll, what I'll do, I'll just copy this and paste it inside, right? So my list is ready, right? And now I have a set, and also let me define the target as well. Target was 15, right? So let's have a set, right? And I want to iterate through the entire list, right? For that, I can use enhanced for loop as well, right? You can read about enhanced for loop, but it basically helps you iterate through any collection, right? So basically, it will help me get all the values one after the other, right? So what I'll check is, let's say my array of j. I'm writing it like this. So uh, let's say this is nothing but array I, array underscore I, right? Now I'll say my array of j will be equal to my target minus array of I, right? This would be my uh, array of j, right? Correct, right? So now I just need to check whether if set actually contains this value or not till now. But one thing to note here. Okay, we'll check later on, but we'll actually be adding each element after we have gone through it. So I'll say my set, just insert the current array of I, right? And when I'll come to the next point, I'll say if it contains, I'll say system dot, I'm just printing out that I have found the value, or I am just printing out the pair. So I'll say array of I plus array of j, right? I hope you understood, right? And also I need to break, because I just need to find one pair and not the all not all the pairs, right? So now you see 8 comma 7, we got the result which we wanted, right? So you can also do this, because j would be present prior to this. If we want to maintain the ordering, you can do array of I comma j, right? And let's say I remove the break statement. Now let's see what is the result, right? We were able to find all the pairs, right? Right, so this break actually make me terminate the program before itself, right? So that's what, right? I will just uh, remove this from here and add it to the code here below. So code, right? So you can refer to it. Right, so this was a classic question which use set. And if I mean this is a classic example where you can see whether you are able to get like how to use set or not, right? So let's come to another question. So this is question number two. Again, I'll write the question, I'll make you understand it, and I'll give you some time to think about it. Uh, so, and again, I am given an unsorted list of integers. I want to find out the number of pairs whose sum is equal to target, right? Now, since I just want to, I don't want the actual pairs instead. And again, please assume that we have duplicates as well. So we want to include the duplicates as well. So let's say there are two sevens and two eights. So the total number of pair would be two. Sorry, four, right? Including 1 7, the other eight, 1 7, and the first one, first eight. Basically, what I mean by this is it's a 7 comma 7 followed by 8 comma 8. So this 7 can combine with this 8 to form 15. This 7 can combine with this 8 to form 15. Similarly for this. So this would result in four pairs and not just two pairs, right? Or one pair if you remove the duplicates, right? So you need to maintain duplicates, right? And again, if no pair exists, just return me -1. So here what we could have done is, I mean, we didn't print -1, but you can add that condition, right? Since we are just printing it out, so that's why I'm not. Yeah, if no such pair exists, we need to return -1. And let me give you the list: 1 2 3 7 5 7 8, followed by another 8, then another 8. I think let's have 4 times 8 and then 10. And now the target is same, 50, correct? So just quickly think about it and then we'll be discussing it, right? So again, I'm running a timer, right? So the timer has started, so you can think about it. Right. So I hope you have gone through the question. Right. Let's jump back. Right. So here, what we want to achieve, right? So first thing is we want to find the number of pairs whose sum is equal to the targets, and we have to include the duplicates, right? So okay, let's see what will be the result, right? First, let's see if anything. So see the set, the property which we use in set in the similar question, that would be used in any way, anyway, right? That has to be used. But can we use a set? We can't, because we need to include the duplicates, right? So that's where the problem arises, right? And also for the duplicates, let's say I'm at this 8, right? I want to find, or I want to find how many sevens are there previously, right? With which I can add and form 15. So there are two sevens, right? So we actually needed the frequency of 7 to find the result, correct? So what we will be doing is we'll be computing the frequency of each element, right? So let's say we have two sevens and we have four eights. So can you tell me how many pairs will we get using a 7 7 and 4 times 8? How many pairs can we get using these? So basically, it would be 2 into 4, right? We can have 8 pairs. This 7 can combine with all these all these eights, and this 7 also can combine, right? So that actually is 2 into 4, right? So if we have the frequency, I can directly do frequency of I multiplied by frequency of j. That would be my number of pairs that would get added to the result, right? You're getting my point, right? And also 7 8, please ignore this 7 8 and 8 comma 7, these both are equal, these are no different, right? We don't, there's no difference between 7 8 and 8 and 7, right? So you can just ignore it, right? So first what we'll be doing is we'll be computing frequency of each element. This you'll be doing using a map. I'll show you how. Basically, I'll be inserting each element in the map. If it is already present, I'll increase. So what I mean by that is, let's say I have a map, right? First, let's say map contains nothing. So so it's value versus frequency, right? So this is like value versus frequency. This is the key value. So key is value, and your so, okay, this is confusing. Key value, let me say element versus frequency. So your key is element and your value is frequency, right? So now why I am at this. So there was no one, there's nothing present. So it's simple like this. And now we have two colon comma one, then three. Similar to this, we have five, then we have 7, right? So against 7 I'll be having 1 for now, and all these are 1 as well, but I didn't write it because it's going to be 1 only, right? Right, so now I come at a point where I encounter another 7, right? So I'll just increase the frequency, then I'll come, the 8 would come, so the frequency of 8 would keep on incrementing till 4, and then 10. So this is my this is my how my frequency map would look like, right? This is what we'll compute using a map, right? So here we are using a map, and then I'll be going through each value, right? I'll say I'll see how many times 7 has occurred, and uh, okay, and 7 has occurred, I'll multiply that with 8, and also I need to actually make this as 0. I'll tell you what I mean by that, right? Okay, let's say I am iterating through this map. I come at 1. I see whether one has any, one makes a sum of 15 with by getting added to some value. No, right? So what I'll do is I'll make the value as 0, right? Then I'll come to 2. Is there a 13? No. So I'll make this 0. I'll come to 3. Is there a 10 present? Is there a 12 present? No. I'll make this as 0. I'll come to 5. Is there a 10 present? Yes. So I'll do 1 into 1 and my answer would have 1 for now. Right? I'll make this as 0. Right? So that when I come to 10, I already told you, right? This 7 and 8 and 8 and 7. Where did I write that? I think I deleted it, but let me just write it again. 7 comma 8 and 8 comma 7, the same 8 comma 7 are identical, right? We don't need to add, we need don't need to count them again, right? So I'll make sure I make this as 0, so that when I come to 10 I don't use this again. I don't say 10 comma 5 is another pair. Got my point, right? So that's why I'm making it 0. So I come to 7. I'll see whether 8 is present. Yeah, it is present 4 times. I'll just add 2 plus 4, which is 8 here, right? And I'll make this as 0, right? I come to 8. There's no 7. 7 frequency is 0. It won't matter, and I'll make this as 0 as well, again for this as well, right? So my answer would be 9. This would be my answer, right? So I hope you understood what I mean by that. Sorry, what? Okay, let me just do one thing. So let me say, okay, let me just do command Z, because okay, let me just do this, right? And after this would be my second point, computing the answer. So you'll be doing like this, like you'll be making it 0, and my answer would become 7 and 1 plus 2 into 4, right? Which will come down to 9. So this would be my answer, right? So now we just need to code it, right? So let's see how we can code it. So first, again, let me copy paste the same list from above, and I'll just modify the list, right? So this will remain same, and this is code, right? And let me just copy this the same list from above. One might say, are there no other methods by which we can solve this? There might be, right? There might be, but you need to see the most optimized approach as well, right? So this is my array list and this is my target. So this is given, this is already given, and I want to find answer, or let's say count. So I'm initiating the count as 0 initially, right? What I'll do first, I need to compute the frequency, right? How we can do that? I already told you. I will use a map, and for every integer I'll do integer comma integer frequency map, and this would be a hash map, which we have already seen, right? If you want to see the implementation of it, you can check out this, right? Okay, so for no since I am starting with it, so let we need to iterate through the list. So again, I'll use um, enhanced for loop for the same, and I'll say this is element. I'll iterate through the list, and what I'll do, if frequency map dot contains key, right? If it contains this key, I would say, okay, something it's suggesting, is always first. No, I'll make sure. If frequency map contains key, I'll do frequency map. Okay, I think the spelling is wrong. Let me correct that. Put. What I'll do is I'll say element comma frequency map dot get element, and I basically we need to do plus one, right? So whatever value is there already, I need to get that, and I'll do a plus one onto it, right? This is what I'll do. Else what I'll do is I'll put frequency map dot put element comma one. I'll initiate, right? So if you want to see, I can also show you for. Okay, let me just do system dot out dot print frequency map. Let's see what exactly it contains. Right, so it contains one against one. That see this map only, right? Whatever we computed, exactly that. You can see that, right? So this is present inside this frequency map. So first point is complete. We are able to compute the frequency. Now what we need to do, we need to iterate through the map, compute the second step, which is compute, and make the value zero as well. That is very important, because otherwise sorry, not compute, basically find the sum, find pairs, right? So we need to make it zero as well. So this step we need to do. I'll iterate through the map. I'll find whether array of I is the current element, whether is basically it's actually this thing, right? This thing I'll be doing. If set contains this value, you got point, you got what I'm trying to say, right? So first, we have already seen how we can iterate through map. So if you can see entry set, I'll just use this now, right, to iterate through the map. So I'll do for map dot entry, and inside this we'll have integer comma integer entry, and what was the name, frequency map dot entry set, right? So my int key would be having entry dot, no, entry, yeah, entry dot get key. This would be my array of I, basically, right? Correct. And I'll say frequency of I would be entry dot get value, right? This thing, two, four, these things, right? Okay. I already mentioned here, this is nothing but element versus frequency, right? So this is the value and this is the key, right? So now what is my array underscore j? It's nothing but my target minus array of I, right? Similar to what we did in set, right? So check if frequency map dot contains key, right? Array of j, if this is present, right, what I'll do is I'll do multiplication of both, right? What I mean by that, I'll find frequency of j, which is will be equal to frequency map dot get array of j, right? So my count would be incremented by frequency of j multiplied by frequency of I, or frequency of I multiplied by frequency of j, right? So this is what we did here, right? One was 1 into 1, and this was 2 into 4, right? So the count is 9. And one thing we are missing here, which is making this 0, making the frequency of Any one of them you can do. So I can also say frequency map of we can do for both as well, that's not an issue, right? I can do put um, array of j as 0. Let's do it for both, right? Even if you don't find, I can do frequency map dot put for array of I, and I can say it is 0. Correct? This is what I need to do, right? And now if I print your result, right, which is count, I think it's count only, right? That's what I initiated. Correct. So you'll see the answer is 9, which we computed as well when we were designing the algorithm, right? So this is how using the simple collections we were able to actually solve a very good problem, I would say, right? So okay, what it is saying, I think it's method returning count from along. No, no, we don't need that. But let me just comment this down, right? Uh, okay, and okay, let me just go ahead. Uh, right. So one topic which we are left with is actually queue. We haven't discussed about queues, right? So we'll discuss about queue now, and then we'll see a question on queue, and we'll complete that, right? Okay, and let me first quickly explain you why we don't use why it is recommended to use, why did I say you should actually use this, not this hash map is equal to new hash map instead of this. Okay, why what's it is saying? Oh, okay. So sorry, this should be hash set. Right. Why I recommended you to use this instead of the above statement, because we should always see. Acha, let's see whether one might say, well, can't we actually use this only? See, every other hash set, reset, linked list, linked hash set, all these are coming from set class only, right? Set interface. Can't we do this, right? Can't we just say set, right? It would say it is abstract and cannot be initiated, right? So, acha, can we do this? Right. So this is actually known as anonymous inner class. If we actually implement all these methods, we'll be able to get this is also used in lambda expressions as well. If you study about that, you will get to know, right? Again, that is a separate topic. Lambda expressions are used with functional interfaces. For that, you need to know about functional interfaces, right? But yeah, for now, I'm saying where if you actually implement all these methods, you'll get another implementation. But why should we do it? We already have all these concrete classes for us, right? Which we can directly use. So I can, instead of naming the interface, I can interface or abstract class. I can actually say, is it an abstract class? Yeah, it's an interface, right? So I can actually say hash set. But why did I say we should use set instead of hash set here? Because this is actually your this is your what do you call interface, right? This is actually the blueprint according to which all the classes will implement. But in the concrete classes, we also can have non-overridden methods as well. We can have that, right? But let's say today I am using hash set implementation, right? And I'm using set dot uh, add contains all these methods I am using, right? But in future, let's say if I'm actually doing this, whatever methods which are defined in this hash set, only those methods would be visible which are also there, which are overridden. So that means even if I change this to tree set in future, right, then also those functions would work, right? So that's why it is always said, always program to an interface and not concrete classes. because interfaces won't change. Concrete classes might change, right? So that's the main important thing, right? And we also studied about anonymous inner class, so you can read about it. Basically, anonymous inner class is, as the name suggests, is the class is the implementation of an interface which doesn't have any names, right? You can basically define all the methods, but there won't be any name, right? So basically, and what I'm saying is interface is actually blueprint for a contract. So you should be doing this and not this. Let's say do this and not this, right? Right. So I'm just commenting this down, and we'll move ahead with the queue interface now, right? So in queue interface, we'll majorly have priority queue. It's actually opposite to what stack is. Stack is last in first out. Queue is first in first out, right? DQ, array DQ. But today we'll be discussing priority queue or a heap, right? This is a FIFO data structure, which means first in, first out, right? It's similar to queue in real world, right? If you come first in the queue, you'll get whatever you want to first, right? Right, let's say you are booking, trying to book a ticket, right, and it says you are in the queue. That means you'll get if the tickets are selling on first come first serve basis, then you'll get the ticket first if you are standing in the front, right? So coming to the priority queue, right, a priority queue is used when objects are supposed to be stored based on priority, right? If we want to store based on priority, right, right, and it also use some comparator class, right, for ordering, right, or basically for priority. I'll give you a question, and then we'll discuss based on priority queue, right? So basically, Java by default provide two implementation. One is a max heap, and the other one is a min heap. You can use any other custom comparator as well to store the element based on your compare what based on the condition you provide in the comparator, right? But max heap and min heap are there by default, right? So let me first show you how a priority queue works quickly, right? And this would be a priority queue, and again, I would say you can use queue here, right? So that won't make any difference. Priority queue dot add. First, let's say I add 20, then I add sorry 10, then I add 20, then maybe 5, right? So let's see what gets printed out first. System dot out dot println, and if you see there's a method called poll, or sorry, peak, right? And let's say I do priority queue dot poll. Poll means removing the element, and peak means the topmost element dot peak. And again, let's say I poll it. Let me just copy this, right? Let's see what the result is, right? Right, so we are getting the minimum element at the top. That means by default it's a min heap. The result is a min heap, correct? right? So right, so let me give you a question quickly, and what we need to do is right, and okay, what we need to do is we are given list of integers, given a list of integers, um, and what we need to and a value k. We need to find the kth largest number, right? So let's say the list is okay. Let me do. Okay, the list is 1, 2, 3, 5, 7, 10, 4, 8, 3, 2, and 20. Right? Let's say this is the list, right? And I want to find the kth largest number, right? So, uh, so let's see what all methods can be. We'll just think about the methods, and then you can code it on your own, right? So first thing which comes to my mind is, which can come to anyone's mind is, we what we can do is we can sort the list, right? And after that, my answer would be, since I want to find the kth largest number, I can say my array of size minus k minus 1. Let's see I have a list of 1, 2, 3, 4, 5. I have it's a sorted list. So I want to find the second largest number. So I can say 0, 1, 2, 3. Array of 3 would be my answer. So array of size minus k would be my answer. Right. So this would be my answer. But what would be the complexity of it? Uh, the time complexity of this would be order of n log n. Right. Or I can show you as well. Arrays. Okay. First, let me create a list. I'll just copy a list from above where I have created one like this, and then I'll paste it below. Right? I'll just copy this list, add it here. Right. So, and let's say my k is maybe, let's say, fourth largest I want to find. Right. So, what I'll do is I'll do arrays dot sort, and I'll provide this list to it. Okay. So I think list dot sort, and comparator, right? So basically you can sort the list, right? This is one way, right? And you'll get the result, right? Okay, let me just do it for you. Collections dot sort, and inside this if I provide list, right? So this would sort the list for you, right? And let me just do sys out, and I want list dot get index would be my list dot size minus k, right? And also please print me the sorted list as well, so I can validate, right? Let's run this. Let's quickly run this. Right. So okay, let me remove all this because we don't need this. Right. So sorted list is 1, 2, 2, 3, 3, 3, 3, and then 20, and I want fourth largest, so 20, 10, 8, and then 7, right? And also if you note, we have the duplicates as well, right? So the duplicates might be a problem. I'll show you how. Let's say I want seventh largest or sixth largest number. Okay, The one, two, three, four, 5, and 6. The 6 is fine. Till 6 is fine. Let me do 8th, right? So how many integers are there? Unique. One, 2, 3, 4, 5, 5, 6, 7, 8, and 9. 9 integers are there. I want the 8th largest. So that should be, ideally should be 2, right? This would, this is giving me 3 because there were duplicates in between, right? So duplicates will be a problem in this case. Again, what we can do is we can add all the values to a set, all the values again back to a list, remove the duplicates, and then do a sort. That also, that in that case we can do that, right? So what we can do is add the values to set, add them back to list, sort, and then the same process, sort, find, right? So let's do that first. Let's do that again, right? So what I can do is I can have a set of integers, new hash set. What I'll do is for I just iterate through the list and won't sort it as of now, right? I'll just sort it later on when I add them back to the list. For integer element, I'll go through the list, set dot, or I can do, what I can do is I can do set dot add all as well, right? Here if I provide the list, it will add all the elements. So this method is also which you can use, right? And now what I'll do is I'll do list is equal to new array, or let's have another list of integer, list 1 is equal to new array list. And what I'll do is list 1 dot add all, right? And then I can use the set to add all the values back to this list, right? Now if I sort the list and find the answer, sorry, command C, right? Now if I run it, right? So here you got the answer as 2, and even you can see the duplicates are not there, right? So this is the solution when the duplicates are also there, right? So you see that we are able to achieve the duplicates problem. I mean, we are able to solve the duplicates problem as well using an existing data structure which we have already studied, right? Using set, right? But let's say I don't want to do this. Instead, okay, let me again go back and add this on the top so that uh, this, let me do this, and this this would be list, again this would be list, right? Right, so this is another way, right? Second solution. And okay, now coming back to this main solution, which will help us achieve the best time complexity, right? What we can do is I can use a max heap, right? How a max heap will be helpful in this case, right? So first let's see how the elements are inserted in a heap, right? Let's say we have 1 comma 2 comma 3 comma 5. These are the elements which are there, and let's say I want to insert in the heap, right? So I'm talking about max heap, right? So let's say first 1 is inserted, okay, and then 2 comes, right? It will see 2 is greater than 1, right? So 2 will be inserted here and 1 will be inserted here. Then 3 comes, right? So it sees 2 is lesser, right? So it will remove and it will do this, right? And then 5 comes, it will see 5 is actually greater than this. So let's say 3 comes here, 3 comes here, then it will see 2 is actually lesser, so it will basically do this, something like this. 3 would come here and 2 would come here, right? Or the other way around as well, right? Um, right, so it would look something like this, right? This is known as a heapify operation. You can learn more about the heapify operation, right? So that is one thing. And similarly for min heap as well, right? So we'll be using, you need to use the min heap. I'm giving you an hint, right? And what you will be doing is uh, you will keep, the solution would be, you'll be keeping, keep the what do you call, um, yeah, you will keep the size of heap as k always. And when you, and keep on inserting elements, so at every point you will check if uh, the current value is greater than top of the heap, you will replace it, or you will insert the element, right? So it's something like this, right? You'll replace, or you will add, basically add the element. If it is not, if it is lesser, that means this element need not be added. So it goes something like this, right? So this is the question, and this is a, this kind of a homework as well. I'll post the solution here itself, and I'll add it to I'll add it on my GitHub, and we'll provide you the link in the description, right? So this was about collections API. I hope it was interesting, and I hope you got the complete understanding how to use collections and how to use it for problem solving as well, right? And what all interfaces are there, why we should code directly, why we should not code directly to an interface, and rather we should code to concrete classes, right? I hope you enjoyed learning, and for more such interesting videos you can come back to Geeks for Geeks. So happy learning, and goodbye. Yeah, okay, so there's one question. Can you explain line 411 again? So let me see. Okay. Okay, check if the value, okay, let me just show you as well, right? So what we will do is, for, see, this would only happen if the size is equal to k. Okay, let's say my heap is full, right? Let's say my heap is full. That means it contains k elements, right? And that means the k largest elements till now are present, already present, right? But we will check if the current current element is actually greater than what is present at the top, heap, top of heap, right? If the current element is greater than the top of heap, what we will do is we will insert the new element. Why we would do so? Because see, we want to find the k largest elements, right? If this element is this is a min heap, right? The minimum element is at the top of the heap, right? If the element is actually greater than the min of heap, that means that element is not needed anymore. This element should be in the k largest element and not the existing element, right? So this is what it means. I'll provide the solution, so you can go. You can try once using these hints, and you'll go through the solution if you are not able to get it, right? But okay, or maybe let's just okay. Have we written down the list? I think the list is there. Okay, let me just actually do the solution for you, right? I'll pause the video and add the solution and put it in, put the link in the description. Okay, so Yeah, bye bye. Happy learning.